Hello and welcome to this roundtable on SPE, Single Pair Ethernet, hosted by TE Connectivity. My name is Mark Maas and I will be facilitating this roundtable. Don't forget, during this session and also after the session, you can add your questions in the chat window. I will now introduce briefly the panelists in this meeting, starting with Alex McGay. He's our VP and CTO within the Industrial Business Unit, so responsible for the engineering part. Next is Ruud van der Brink. He's a product manager within Industrial Communication and responsible for the EMEA region. And we've got Ted Czarkowski, product manager, also within Industrial Communication, but then for the Americas. And last but not least, Pete Smith. He's within the sales and marketing division of Sensor Solutions. Welcome all. So let's start with this roundtable, and let's start with trying to find out why single pair Ethernet is relevant. First question, Ruud, can you explain a little bit more on what is single pair Ethernet?
Yeah, I think that everybody has heard of the terminology Ethernet and is very familiar with the present variants of Ethernet that are around. 4-wire, 8-wire variants, RJ45 plugs and connectors to terminate those connections. Single pair Ethernet is different from the fact that it is only one single pair that is used for the transmission and also when necessary for the power of the remote device. Yeah, single pair Ethernet, as said, it's an addition to already existing variants of Ethernet with a specific, let's say, industrial user case behind it.
Okay, thank you, Ruud. Then Ted, if you can elaborate a little bit on the benefits and why is SPE relevant to customers?
Yes, sure, Mark, and thank you. Yes, so the main benefit of single pair Ethernet, SPE, is that it provides a single, open, and scalable Ethernet-based network within an automation system. As a result, this generates many opportunities for our customers, such as miniaturization of devices, increased efficiency of devices, and also remote power feeding mentioned by Ruud. As you know, historically, multi-wire infrastructure was needed for fast 100 megabits per second Ethernet, and even more wires for gigabit Ethernet were required. Now, with SPE, only 2 wires are needed for data and power. As you know, or we're gonna explore that, SPE offers POODLE, power over data line option, as well as hybrid data and power line alternative. This significantly reduces network complexity, costs, and enables customers to go beyond existing borders. Today, customers need more efficient infrastructure as the automation field level has grown significantly. More and more sensors require transmission rates that field bus systems can no longer support. At the same time, the existing Ethernet infrastructure is too expensive, too large, and oversized for most of field applications. Therefore, a slim, lightweight, and powerful infrastructure for Ethernet is needed to enable the industry to digitalize at the field level, and therefore take the step into IoT, which is Industrial Ethernet, Internet of Things. This is where SPE comes in. Thank you, Mark.
Thank you, Ted. It was quite a nice list of benefits. Ruud, can you elaborate a little bit more on which applications SPE is relevant for, and is it more suited for greenfield or for brownfield or for both?
Yeah, thanks, Mark. Yeah, like Ted introduced, Ethernet, single pair Ethernet is addressing a gap, especially if you look at the edge of the network, which is traditionally, let's say, connected through bus systems and serial communications. SPE is a solution that brings Ethernet to the network edge. So that is in the case of IoT, as Ted says so, and Ethernet all over the place. Single pair Ethernet is then having an advantage that the total network can be addressed through IP network addresses, and it also has the other advantage that the gateways that are necessary to bring bus data into an Ethernet world and the other way around can be removed out of the network. So all in all, a number of advantages, both from a cost point of view as well as from a transparency point of view. Greenfield and brownfield, if we look at the adoption of such technologies, they are likely to be adopted in smaller rollouts that can be hooked up to the traditional 4-wire or 8-wire Ethernet. And I think that they will be a kind of a greenfield in a brownfield application space. Thank you, Mark.
Okay, thank you, Ruud. Pete, from your end, from the sensors perspective, anything to add here?
Yeah, there are a couple things I'd like to mention. First of all, the adoption of SPE is going to help solve a particular problem we have in sensors. To be compatible with so many different systems and capabilities out there, we have to offer sensors, as an example, with 9 different connector types. And this is the physical connector where you actually make connection. And among those 9 different types, we have to offer the electrical output in 7 different formats. And so what it does is it creates a very complicated formula that you have to think through when you're designing your system, what particular connector types and what kind of electrical formats you want. SPE will bring a standardization to that so that everything will be using similar physical connector types, and will be using similar interface types for the electrical signals. So we view this as a big benefit in terms of reducing cost and adding simplicity to the whole system.
Yeah, this definitely sounds like almost a dream in reducing complexity. Very good. Ruud, you already briefly discussed on IoT, the Industrial Internet of Things. How does SPE fit in there? How does it support the Ethernet everywhere?
Like said, the traditional industrial networks are today built up out of Ethernet portions, bus portions, and serial communications. And especially the bus and serial communications, you'll find at the network edge. IoT, and actually bringing Ethernet everywhere, is replacing the traditional technologies at the network edge by an Ethernet solution that is a complement to the already available Ethernet in such a network. Bringing Ethernet to the edge is bringing the advantages of having a total flat network with only one transmission technology, avoiding, as said earlier, all the gateways and translation requirements between the various transmission systems that are used in today's network. What is, I would say, relevant in this is that it can be done quite easily, interfacing single pair Ethernet to the traditional Ethernet network infrastructure by using media gateways, and that can be the connection between the old style, old world Ethernet and the single pair Ethernet at the network edge. Thank you, Mark.
Thank you, Ruud. Alex, from an engineering point of view, do you have anything to add to what you've heard before?
What I would like to highlight once again, and this was already mentioned before, but looking from the customer's perspective and from customer's system architect perspective, single pair Ethernet provides really a ton of benefits. on one side, flexibility. So in terms of being able to connect any end device at every node of the network, and then drastically reduce complexity on what we just spoke about. And this combination of increased flexibility and drastically reduced complexity, this is actually the absolute plus point from, if we look at it from the customer's system architect's perspective. This is something, and just one thing also to add, it's not only transitioning of data, but what was mentioned a couple of times before, power over data line. So simple, smaller sensors can also be powered by this network as well. And this once again brings an additional degree of freedom in terms of flexibility. So I think this is definitely a win-win for our customers. Thank you, Mark.
Sounds good. So reduced complexity, more flexibility, that all sounds good, but in the end, everything is down to cost. So Ted, can you comment on the total cost of ownership that SPE can have benefits on?
Yes, Mark, definitely. So single pair Ethernet SPE can potentially replace all field bus technologies because it enables Ethernet only automation. As SPE is standardized in IEC 6163171-6, it offers both IP20 and IP67 solutions. Single pair Ethernet provides data transmission rates up to 1 gigabits of transmission rates over a single twisted copper pair. By reduction from 4 or 8 wires of the traditional fast Ethernet and gigabit Ethernet towards 2 wires, this technology enables smaller connector sizes and decreases the termination effort. It is suitable to bring Ethernet down to the sensor level and to connect sensors directly to IT systems, or you may refer to it as a cloud, and to support the added value services of the industrial Ethernet of Things, IoT. Single pair Ethernet cable is smaller. It is also less costly compared to conventional 2 and 4 twisted pair construction. So specifically, cable diameter with SPE is reduced by about 25%. There's also less cable weight, smaller cable, less weight and volume of the cable, and reduction of potentially up to 50%. In addition, the amount of hardware needed to implement SPE is reduced versus field bus because devices such as gateways are no longer needed. Subsequently, this saves installation space and costs. So overall, the construction, operation, and maintenance of automation system becomes more efficient and cost-effective. In conclusion, for the first time, Ethernet can communicate space and cost efficiently from the cloud to the field level, and total cost of ownership can be drastically reduced, especially in comparison with traditional field bus systems. Thank you, Mark.
Thank you, Ted. Pete, from Sensor's perspective, what would you like to add to this?
We are starting to see from the sensor side some inquiries from customers asking us to provide multiple sensor capabilities for specific applications. And to address that, we are actually in the process of creating what we call multi-sensor modules. I think another word that's sometimes used is fusion, where we're sticking 2 sensor capabilities in the same package. And for example, we'll do a pressure sensor and a temperature sensor in the same package, or we might do a speed sensor and an accelerometer in the same package. And what that does is it provides a cost advantage, particularly to the customer. And SPE allows us to communicate the data from both of those sensors over a single pair of lines. And so This reduces the cost of cabling, reduces the cost of installation, and it makes a much more compact package so that we're actually taking up less space on the equipment that's in a factory. So this SPE is very, very beneficial to implementing some of these multi-sensor modules that we're working on. So it is a big help. Mark, back to you.
Thanks, Pete. Well, that's good to hear, all these benefits. Ruud, if you then look at some examples of where SPE is used and what kind of applications in the factory would that be?
Yeah, thanks, Mark. Yeah, if you look at the traditional Ethernet, the 4 and 8 wire Ethernet, there's one thing, a big limitation, and that is the length of the connections. It goes up to 100 meters, and with a repeater, it can go up to 200 meters, but that is all. If you look at a typical factory environment, you see the shorter connections that are there, and we would be able to address them with single pair Ethernet at speeds of 1 gig and 100 megabit. However, not only the short distances are of interest in such an environment, but also the longer distance connections. The point-to-point connections up to 1 kilometer covered by the field buses today can be covered by the 802.3CG standard in single pair Ethernet. We've seen already a number of active devices that can bring that distance even up to about 1.7 kilometers, so well beyond that particular standard. So that is addressing one. And then there is another type of application where a single pair Ethernet is playing a vital role, and that is not in the point-to-point, but the so-called multi-drop environment. That allows you to bring a number of peripheral devices very close on a bus-like system, like a 25 meters long and up to about 8 devices simultaneously, offering a structure which is more or less similar to a field bus application and implementation, but based upon the Ethernet technology. Thank you, Mark.
Okay, thank you, Ruud. Ted, any more examples from the Americas? I think you're still on mute.
Yes, Mark, do apologize for delay here. Another application example and potential use case here could be the one associated with an example of warehouse automation. And in particular, as logistics facilities continue to be in high demand, with examples of companies such as Amazon, FedEx, or UPS, there might be applications with conveyor and sorting systems. As powered conveyor rollers require relatively low power, there could be applications not only to power the roller itself, but also provide Ethernet communication to it. Single pair Ethernet, in this case, would not only reduce the cost of wiring, but also provide predictive maintenance capability, therefore allowing customers to avoid costly equipment line down, which is so critical to such facilities. Thank you, Mark.
Thank you, Ted. Okay, that sounds great. A lot of benefits, a lot of examples. Now let's step into the next topic. Alex, obviously TE is hosting this roundtable, but why would TE be a good partner for companies that want to step into SPE?
Thank you, Mark, and this is a great question. We need also to recall the first point that SPE has already its place in other areas than industrial. So it means, for example, in the automotive area, it has been around for quite some time, and this actually giving us the scale, and us, I mean the industry, the scale to work with the semiconductor companies which are manufacturing the active devices. But it also gives our customers insurance and assurance that TE is the right partner, because we've got some experience from our colleagues in the automotive business unit that we've got this experience to work with the single pair Ethernet. So this is one point. Another point, obviously, our expertise in the connectivity area, in the industrial communication area overall. And the last part is obviously the scale and our long-lasting experience in the industrial space as well. So connecting these three areas is experience in the automotive area, scale and expertise in the industrial communication area. These combinations will give our customers, so OEM suppliers and end users, assurance that TE is exactly the right partner to roll out the SPE implementation in your domain as well. Thank you, Mark.
Thank you, Alex. Ruud, we've been talking a little bit about standards already, but which standards are relevant if we talk about SPE within industrial? And how is TE driving these standards?
Yeah, there's a couple of different things here, Mark. And first of all, IEEE with the various 802.3 standards. Examples are BP, BW, and CG. And these are standards, transmission standards on point-to-point links with distances of about 40 meters. And in the case of very long connections, over 1 kilometer. These IEEE standards are also defining the related transmission speed for those stretches of Ethernet that can be covered. So that is the network side, length and transmission speed. Next to it, there is the IEC, and the IEC is defining the connector standards. IEC 63171-6 is the predominant, let's say, standard for single pair Ethernet connectivity. It offers connectivity both in an IP20 world as well as in an IP67 world. And next to remote powering over the data lines, the POODLE, let's say, implementations, it offers a connectivity family which we call a metric hybrid connectivity, and that is next to the two signal lines. It offers additional connectivity to power up to 8 amp remote powering. So for TE, it is extremely important to be part of those standardization groups, IEEE, single pair Ethernet, and actually drive the standards and update the standards where required with respect to single pair Ethernet. Thanks, Mark.
Okay, thank you, Ruud. Well, good to hear that TE is taking a very active role in there. Alex, what else does TE contribute to the rollout of SPE?
Thank you, Mark. Is the first point I just would like to reinforce what Ruud just said in terms of driving standardization. And this is nothing what we can do by ourselves alone. So the -6 standard was developed and was published earlier this year, so in January 2020. This was a result of the close collaboration with multiple suppliers of connectivity who worked together on this standard. So this really needs to be highlighted. So no single company can do it by itself. This is why we work together with our competitors and some of our customers to develop the standards. And TE takes a very, very active role in the definition and development of these standards. And also, it's not only about developing standards, but also developing products and developing connectors or connectivity solutions to show how this can work in reality. And in our product, there is already some products or some connectors already on sale, so especially IP20 solutions, but also further solutions in the M12 form factor already in the pipeline. And these are only two small examples of what is yet to come from TE connectivity. Thank you, Mark.
Thank you, Alex. Yeah, I think it's a very valid point, and it is not something that TE can do on its own. Ted, I've heard that there is an SPE partner network. Can you elaborate a little bit more on it and explain what the role of TE is in it?
Yes, sure, Mark. Yeah, so SPE partner network had been formed a while ago. That's going to be over a year ago. TE Connectivity is a proud founder and founding member of the SPE partner network. Together with all members, TE is driving this technology to become a standard in the industry. The SPE Industrial Partner Network is based in Rachten, Germany, and it is an association of companies that promote single pair Ethernet technology as the basis for rapid and successful growth of the IoT, Industrial Ethernet, Internet of Things. For future users, the network is the first point of contact for all questions concerning standardization and construction of SPE networks based on components and devices which create an SPE ecosystem. Partner Network provides clear recommendations for the development of future IoT applications, and it is a central information and exchange platform for all participants. By combining members' competencies, the partner network provides users with security that the technology is to be relied upon. And of course, anyone can join the open SPE partner network. You are welcome to join. It is easy to sign up by visiting our website. You will be guided to all the instructions allowing you to become a member as well. Mark?
Thank you, Ted. Pete, anything to add from your end on this?
Yes, I'd like to mention that TE is well known for its connectors and connectivity and cable solutions that they offer to customers. And maybe not quite so much known is the TE has a business unit that's dedicated entirely to sensors. And so we represent, I guess a good word to describe it would be a one-stop shop. We can provide you the interconnect capabilities of SPE, cabling, and the expertise to help implement that. But we also have an entire business unit dedicated to sensors. We do a wide variety of sensor products, temperature sensors, pressure sensors, accelerometers, tilt sensors, position and motion sensors, speed sensors. And so we can provide many of the sensor products that you might need as you're developing a system for smart factory applications, industrial IoT, and we're developing a number of new products that will specifically play in this area. So when you're talking to the teams on the connectors and the cabling for SPE, don't forget to ask about some of our sensors. I'm acting like a salesman here, I'm sorry, but we do offer a wide variety of sensor solutions to the application in smart factory. So don't forget that we are a one-stop shop from that perspective. Okay, Mark, back to you.
Thank you, Pete. Well, it's nice to see that SPE is providing Ethernet everywhere, but we can provide the products that go along with it everywhere as well. That's nice to hear. Ruud, anything to add from your end?
Yeah, I think I already talked earlier in this roundtable about standardization and the importance of standardization. One thing very closely related to that is the so-called user groups. the conglomerates of companies that are fulfilling a certain approach for a specific application domain. Out of those user groups, there is an interest for alternative technologies because at this very moment, some of the application domains are not addressed in the most optimal form. As such, we see them reaching out to us as TE, but also to the industrial partner network to get educated about single pair Ethernet, to get an understanding of the technologies and the advantages that it might bring in their application space. Examples of such user groups are the ODVA group, P&O, CC Link, and some other global initiatives. We as TE and also as part of our industrial partner network are in continuous dialogue with these type of user groups. Thanks, Mark.
Thank you, Ruud. Continuing with you, Ruud, if we look at SPE and the whole infrastructure there, what needs to be in place before SPE can adopt it on a broad scale in the industrial world?
Yeah, I think you already put up a very nice slide that addresses that particular story. But first of all, of course, the technology is important as a basis, single pair Ethernet technology. Associated to that technology are the standards, and the standards are describing a good number of things. Yeah? The IEEE standards are a good example of that, as discussed, but also IEC as the connector interface standards. And there are more like test strategies, like cable specifications, etc., etc. Then if those standards are in place, what you will see is that the various companies are making the components that are complying to the standards. And if you build an Ethernet port, there's a couple of things you need. Of course, you need a cable that connects to that Ethernet port. You need a connector technology that is allowing to connect that cable to a piece of machinery. And then within that machinery, you need magnetic separation, you need the silicon to support it. So these components allow you to build the devices that are SPE compliant. And in the long run, with those devices, you can build the applications that go and are suited for SPE. So all in all, you need to build up that whole infrastructure and that whole ecosystem to roll out SPE to the rest of the world, or to the entire world, I should say. Thank you, Mark.
Okay, thank you, Ruud. Then, if I may ask that, what is already in place from TE's perspective?
Yes, Mark. TE is actively developing and soon launching a series of products. Those products will include both IP20 solutions as well as IP67 solutions. For IP20 solutions, we are focusing on Poodle, power over data line portfolio. And within this portfolio, we are going to offer both connectors and cable assemblies. In terms of connectors, those are board level connectors that can be implemented on anyone's device. They will come in different formats. There will be female vertical versions. There will be also female right angle versions initially. And on the cable side, there will be cable plug, male, straight, and also right angle versions. With that, there will be field installable connector plug offered as well. On our roadmap, we're looking at including various types of cable options, ranging from 18 AWG all the way to AWG 26, primarily polyurethane, but we'll go beyond that over time. And definitely options with some flexibility to those cables that are suitable for industrial automation types of applications. And then on the IP67 side, that design is a hybrid design we talked about, and that design combines data line and power line in one connector interface. In this case, it is an M8 hybrid connector, and TE's initial offering will include female vertical board level connectors, followed by male vertical board connectors. And in the future, on connector side, they're looking at right angle configurations, and of course, field installable plugs and sockets. And over time, as we been discussing, there is a need for multi-drop types of applications. There will be T-splitters, N-line splitters, and other accessories that will be necessary to deploy such systems. In terms of cable assemblies, we are offering an overmolded cable male plug. There will be female socket as well. These cable assemblies will come in different formats, single-ended pigtails, and also double-ended as options as those will be necessary. As far as cable options here, because this is an IP67 type of solution, we're looking into, again, different types of cables, focusing on polyurethane, PUR initially. We're looking into cable offering that provides direct chain and high flex capabilities in the future as well. So overall, in both cases, IP20 and IP67, we will be launching our initial package shortly. Samples are available of these or both options today, and we'll be advising the world as we launch these products when they become available. We're targeting SPS in Nuremberg this year as the primary timeline for that launch to occur. Back to you, Mark.
Thank you, Ted. So that's an extensive overview of things that are coming. Alex, from your view, do you have a better idea on what others in the partner network are already offering or will be offering in the near future?
Yeah, thank you, Mark. And this is an interesting situation in terms, as I described before, as with the standardization, we need to work with our competitors in the market space to get the technology moving, to get it adopted. And this is the same on the product area. So we obviously work closely with our competitors, and in some area very first competitors, to bring the first products to the area. And the examples which showed, which are shown on this slide, for example, one of our competitors, Harting, also offering similar products. This is just to get the market moving, to get the adaptation of the technology to our customers. Obviously, in the later stages, we will compete again, and we're competing, but just to get this moving, this is why we're working there. Apart from connectivity, there is also a lot of movement, what Ted described on the cable side, but also on the, we mustn't forget also the enhancements or developments on the active side of the things, so on the fire side. And I think Ruth mentioned earlier in the call or earlier in the discussion that there is quite a few developments. And last couple of days ago, I stumbled upon an announcement from Texas Instrument about the chip which is capable to communicate over the distance over 1.7 kilometers. And this is also very encouraging development, especially as it is comes to let's say at a reasonable price. So therefore, I think this combination from the active component, passive components from TE and from our competitors, this will get this technology moving forward and will definitely contribute to the adoption of this technology in the market. Thank you, Mark.
Thank you, Alex. Pete, from the sensors view, what can you add?
I should tell you that our sensors business unit is made the industrial applications for sensors a primary place where we're looking for new business. It is one of the pillars of our strategy that's been developed just recently, smart factory in industrial applications. We're looking very hard right now at the best ways to include the connector capabilities into the sensor package. And more importantly, the connectivity would be part of it would be the firmware and software that's developed. Many of our sensors have recently been introduced in digital formats so that we not only have analog products, but will provide products with digital capability and have be easy for those products to communicate over an SPE type of connection. So we're looking forward to introducing a large number of products into this area over the next couple of years. We have that on our roadmap, and I think it'll be very exciting in the fact that part of TE and the connectors and cabling space and the sensor space, we're all looking at this in the same direction, and I think we're going to see a lot of cooperation between our two business units to provide good solutions for all the customers out there. So that kind of sums it up, Mark, from our perspective.
Okay, thank you, Pete. So we've been sharing a lot of information. Ted, can you elaborate a little bit on where we could find some of this additional information, or where people could find it?
Yes, Mark, definitely. So there are a number of resources available to you today. On our website, te.com, there is a landing page dedicated to single pair Ethernet. And the link and all the information will be shared with you after this roundtable and will be available to you. In addition to an overview page, we also have a video that you can watch. In addition to this information, there's also a website dedicated to SPE network that talks about members of the network, the reasoning behind having the network that we've discussed earlier during this call, and provides you with a number of options in terms of identifying your needs, obtaining questions or answers to your questions, and also signing up to become a member of the SPE Partner Network. In addition to it, there is information available to you from the SPE Partner Network Pioneer Summit, which took place earlier in November. TE experts had not only attended that Pioneer Summit, but they have also presented, and those include some of the people on this call, Ruud van der Brink, but also our engineering staff and research and development experts that you will be able to visit the website, review the presentations, and potentially later ask the questions. Back to you, Mark.
Thank you, Ted. Okay, very clear. If we, Alex, if I ask you to start dreaming a little bit, or use your crystal ball or whatever you use to look ahead 5 to 10 years, where do you think that the industrial world will be, and what will be the place then, or the position of SPE in it?
That's an excellent question, Mark. And let's say looking into crystal ball or making predictions is always very dangerous. But I think in this case, we can always say that the drive for flexibility and to reduce complexity will also come into our space. And I think in one of the slides where we showed architecture of a network, there is a desire to have one network type throughout the entire stack, from enterprise resource planning systems, to the PLC controllers, to the network, to the sensors, and to the end devices. And I think Ethernet is one of the technologies which will win at the end. First, because of its adoption already in the in the industry, but also because of the flexibility from the physical perspective. And in this environment, the place for SPE is to close the Ethernet gap at the edge, what we spoke about earlier in this talk. So closing this gap would be one thing that I think SPE is at the forefront to win this battle for the edge in the network. I think if you ask me, there will probably also space for some of the wireless connectivity, but I think in the industrial environment, especially in the next 5 years, the foremost connectivity will be wired, but we need to ensure that this connectivity is as flexible as possible and also with as simple as possible. And I think SPE as a technology has got its place and will win in this space. Thank you, Mark.
Thank you, Alex. Looking at the time, I think we have to conclude it here. So I want to thank all panelists, and I want to make clear to all the people that have listened into this webcast that you could have already asked your questions, but we will still stay on for a little while to answer any other questions you would have in the chat. Thank you very much for your attention, and maybe see each other somewhere in the future. Thank you. Bye-bye.